What's poppin', dogs? Mr. Allen here. We're about to solve with some trig functions. Looks like we got between 0 and 2 pi, so we're dealing with radians here. All right, we got a beefy one over here. We got a big old equation here. 3 different cosines, man. Now, at first, some people are like, why don't I just divide by cosine, right? Get rid of one. It'll be great. Can't do that, man. You cannot get rid of a function. You're getting rid of a potential solution. Got to leave them all there. So what I'm going to do is I'm going to set it equal to 0 by adding that guy over. So I'm going to have 2 cosine cubed theta plus 3 cosine squared theta plus cosine theta equals 0. And now I can start factoring. I can take out a cosine as a GCF. So I'll have cosine theta, and then we'll have 2 cosine cubed squared, oh my goodness, squared theta plus 3 cosine theta plus 1. Boom, equals 0. All right, so I took a cosine out of each that is squared there. All righty, let's see here. I got myself a quadratic. Thinking I got a factor with that. Oh my gosh, and we have a lead coefficient. Are you kidding me? That's ridiculous. Oh, it'll be all right. It'll be all right. Okay, so we got cosine of theta. I'm going to have 2 sets of parentheses here. Now, if you are a rainbow method fan or like breaking it into factor by grouping, it gets a little challenging with these problems. So I'm going to do a little guess and check. Check this out. 2. There's only one way to get 2 cosine squared. It's having 2 cosine theta and just a cosine theta. That's the only way I can get 2 cosine squared theta if I'm going to multiply those two back together. How do I get 1? There's only one way to do that. Plus 1 and plus 1. There is no other way to multiply to 1. Now check this out. 1 times 2 cosine is 2 cosine. 1 times cosine is 1 cosine. 2 cosine plus 1 cosine gives me that 3 cosine. Guess and check within these trig ones right here that we have when we're solving with trig functions. A lot easier to use guess and check than the factor lead coefficient where you got to like go through all those steps, because most of them pretty small numbers like this, prime numbers generally speaking. All right, now we've got 1, 2, 3 factors, so we're going to set these all equal to 0 and solve individually. So first one here, I've got cosine of theta is equal to 0. So when does cosine equal 0? That would be up at what? Pi over 2, as well as down at 3 pi over 2, right? Beautiful. Beautiful. That's my x-coordinate. Pew, pew. Awesome. All right. Next one over here. We've got ourselves 2 cosine theta plus 1. That means that cosine theta is going to equal -1/2. So when is cosine theta equaling -1/2? Well, if you're a triangle person, we could draw that up. We'd have, let's see here, adjacent over hypotenuse. The adjacent side needs to be -1. So that would be something like this guy right over here, -1. We got 2 right here. That's a √3. So that's a 60-degree reference. This would end up being 2 pi over 3. And then where else would that be? That would also be in my third quadrant here, right? So that's going to be a √3 down here. It'll be negative that time. We got a 2 there. So this time, now we got, let's see here, 1 pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3. It can help sometimes to count that if you haven't done them in a while, but generally when you're doing a lot of these, a lot of practice, you'll be able to just whip them out, right? So we get 4 pi over 3. Beautiful. Last one. When does cosine equal, in this case, cosine of theta is going to be equal to -1. So when does cosine equal -1? That would be the quadrantal right over here, because my x-coordinate on the unit circle is -1 over there. So that's going to be at pi. And there we have it, folks. We got 1, 2, 3, 4, 5 total solutions. Dang. That's pretty dope, man. That's pretty dope. And that's for the situation where you are between 0 and 2 pi. You can also deal with these things unbounded. All right, unbounded here. So maybe we'll save that for another video. For this one, we'll just keep it like this, and then we'll do some unbounded another time. All right, I will see you dogs later.